welcome again to one of our virtual events. We have a very exciting event today with Dr. Daniel Wegert. He is CTC's geology professor. So we're going to learn all about Texas rocks and fossils, and this is one of my favorite subjects. So we are thrilled. We have Janice Wright that's going to be streaming with us today. If you have any questions, make sure that you put them in the Facebook comments, and Janice will go ahead and relay them to Dr. Wegert. Also, if you need attendance information, you need attendance record, make sure that you go to the library website, find events, and then go ahead and register for this event. Well, I am going to go ahead and let Dr. Wegert take it away. So thank you, sir, for joining us today.
Thank you. Hello, everyone. And like she said, if you've got any questions, please say something. If you've got questions about a specific fossil you found in the past, do me a favor, hold those, and at the end, I will give you my contact information, and feel free to send me that information, the pictures or whatnot, and I'll be glad to help you identify whatever you have. But if you've got questions about this presentation, as they come up, please feel free to say something. So let me share my screen real quick here. So we're going to talk for the most part today about Cretaceous fossils here in Central Texas. At the end, I will talk a little bit about a couple of, or one major other type of fossil found here. Now, when I say Cretaceous, what does that mean? Most people have vaguely heard that term, maybe. Cretaceous is a time period from the Mesozoic. This is going to be the time period when dinosaurs roamed the earth. Now, what you're seeing here is the time scale for all of geologic time. So from the beginning of the earth all the way up to modern day. So Cenozoic is the time of mammals, Mesozoic, basically the time of dinosaurs. Paleozoic is everything before dinosaurs. Precambrian is when there wasn't much in the way of life. Now, the rocks in this specific area, right around Killeen Cove, this general area of Central Texas, are for the most part Cretaceous rocks. So all the fossils are from the Cretaceous time period. We've got, depending on where exactly you are, we have early and we have late Cretaceous rocks exposed in this area. And if you look over here, the scale here is it says MA here at the top. That means million years ago. So we're talking about rocks deposited from 145 million years ago up to about 65 and a half, give or take, million years ago. So these are very old rocks, and many of them are full of fossils. Now, the formations in this area, depending on exactly where you are, the formations do change. If you're up closer to Waco, you're more likely to see units like the Austin Chalk. Right here at CTC's campus, basically the Killeen Coppers Cove area, is actually a lower Cretaceous set of rock units. Most of the area is underlain by a unit known as the walnut clay, sometimes referred to as the walnut formation. That's what we're sitting on directly below, for instance, CTC's campus. If you look at the hills around here, though, the hills are actually made of the next unit up, the Comanche Peak Formation. Both of these are lower Cretaceous units. In general, as you head, for the most part, north and a bit to the west, you tend to go up this scale. So the further north and a little bit to the west you go, the further up on the scale you will be. The further south you go, the further down this chart you will end up going. Now, Texas is a big state, and we actually have rocks deposited from pretty much every time period. There's only one major time period that's doesn't have rocks exposed at the surface that I know of. Pretty much every other time period has rocks that you can find. You just may have to drive halfway across Texas to find them. Here in the Central Texas region, we've got these brown and green units right here. These are Cretaceous units here. If you head down towards Llano, you can start to get into some older rock units. If you head north and west of here, you can start to get into older rock units. If you head towards the coastline, in general, you will start to find younger rocks as you get closer and closer to the Gulf of Mexico today. So we're in this general area here, predominantly Cretaceous rock units. Now, one thing I do want you to keep in mind, when we're talking about these old rock units, the Earth has been changing throughout time. So when we're talking about all those different formations, they were deposited one after another throughout time, but the Earth wasn't exactly the same. This picture is showing what's called a paleogeographic reconstruction. This is work done by one group of scientists and what they think the Earth looked like at this time period, in this time period. So this is towards the end of the Cretaceous, or in the late Cretaceous, I should say. And if you look closely, you'll see a few differences. Notice we have a blue line running through the middle of North America. This blue line is referred to as the Cretaceous Interior Seaway. We actually had seawater connecting what is today the Gulf of Mexico all the way up to the Arctic Ocean, cutting North America in half. And if you look closely, this would be Texas. This is why you will not find dinosaurs in most of Texas, because we were seafloor. We weren't dry land. The dinosaurs lived on land. Now, if you go out to West Texas, you can find dinosaurs. Here in most of Texas, though, we were seafloor. So instead of finding dinosaurs, we're going to find ocean-dwelling creatures buried and preserved in the rock. And as you look, this specific reconstruction, you'll see things like Florida being underwater, most of Texas being underwater. If you compare that with this reconstruction, which is put out by the National Geographic Society, this one has a lot of the same features. Florida is underwater. Most of Texas is underwater. You may see some slight differences, though. For instance, there's a body of water over here that wasn't in the other reconstruction. The Cretaceous time period spans 80 million years. Throughout that time, changes occur. Plus, different groups make different assumptions, interpret the data a little bit different, so they may come up with slight differences. What all scientists tend to agree on is that we do have this water body running through North America, and that most of Texas is seafloor. That's what the rocks are telling us. Now, if we zoom in a little closer, you can see parts of western Texas and a little bit of the panhandle, they're dry. So those areas, you can find dinosaurs. Also, sea level's not constant. It changes. So at different times, different parts of this blue area of Texas may have also been dry land as well. So things change, but this is a good generalization to explain why this area we don't find dinosaurs, but we do find a lot of ocean-dwelling creatures. Now, some of you have probably looked at the rocks around here and found fossils before. And some of you may know what you found, some of you may not. What I've got here is just a list of general types of fossils. And I've broken them up based on how common or uncommon they are overall. This is not perfect. As you move from area to area around Central Texas, what is common in one area may become very, very rare in another. So some of this you gotta have to take with a grain of salt because it may change as you move around. But in general, for most of Central Texas, bivalves are by far the most common fossil you will find. Ammonoids, echonoids, and gastropods are also very common, very easy to find. uncommon fossils, you're going to have to hunt for them. You're going to have to look carefully, and you may have to hunt for quite a while before you find any examples of these. And you may have to visit multiple locations to find them. There were not a lot of corals around. I'll explain why here in a little bit. We also have a very special type of bivalve that I pulled out called a Rudist bivalve. Rudist bivalves are only around in the Cretaceous time period. They did not exist in any other time period. We do find them here in central Texas. If you look carefully, you may see worm tubes attached to one or more of the fossils you find. You can also find things like petrified wood and even occasionally shark's teeth. The rarest of the fossils that I have found here in central Texas are brachiopods. This one, if you find it, it's worth noting because I've seen one. Exactly one. These are extremely rare from this area. Not something you'll likely see, but they are here, and if you hunt, you might get lucky. So we're going to go through these different groups more or less in the order that I had them in. So first thing we're going to talk about are bivalves. Now, believe it or not, you actually have heard of bivalves from the modern day. Scallops, clams, oysters, those are bivalves. They're called bivalves because valve is a term for a shell, and they have two shells that open and close, hence bivalve. Now, in this picture, these up here would be the scallops, or examples of scallops. These two here and this one here are examples of oysters. And this one and the ones on the bottom, these are all examples of clams from the Cretaceous time period. You'll note, wide variety of shapes. One distinct characteristic though, as you're looking on these shells, you look down on top of the shells are asymmetric. The left side and the right side are not the same. So no matter how you draw a line through these shells, left and right do not equal. They're different. That's one feature you can look at that'll tell you, yes, this is most likely a bivalve. I'll show you what the brachiopods are the one that's most commonly confused for bivalves. I'll show you them later and show you how you can tell the difference.
So, Dr. Wegert, we have a question
Sure.
from Susan Preston New. She's in the Harker Heights area, and she is wondering where's the best place to hunt for fossils. She'd like to, head out and search with her children.
I was actually going to talk about that later, but we'll go ahead and cover it now. Fossil hounding is a great thing to do with kids because it's been my experience that when you take kids out and let them go hunting for fossils, once they kind of have an idea what to look for, they will spend hours. You will get tired before they will. I've actually run a couple of kids camps, summer camps, where we took kids out to hunt for fossils. And we actually had to drag some of the kids away from the area because they didn't want to leave. They wanted to keep looking. So this is a great thing to do with kids because they love finding this stuff, especially if you can then talk to them a little bit about what they've found. In general, your best bet is to find a location where you have rock layers hitting the surface along a roadway. Those are the kind of the easiest to access. There's usually no rules against it, and it's not somebody's private property, so you're not trespassing or anything. So if you go down a road and there's a rock outcrop right along the side of the road, that's usually one of the best places. What I've seen here in central Texas, if you got a big vertical rock face, don't bother. What you want is you want someplace where it's almost like a hillside leaned back a little bit away from the road, and it'll almost look like gravel coating that rock face. Those are usually some of the best places. Because as the rock weathers, as water and other processes start to break down the rock, there's a weakness between the fossil and the rock the fossil's in. So oftentimes the fossil will break out of the rock and be sitting there all by itself. So very easy to pick up and you don't have any extra stuff to haul around. Most of these fossils, you notice there's no real rock stuck to them. It's just the fossil. They come out of outcrops like that, where Mother Nature has broken the rock away from the outside and left it lying on the surface. So pretty much anywhere along a roadway, because in general, if right along the roadways, the rock outcrops along the roadways, that's basically public land. You can go and collect there. Just don't cross any fences. If there's a fence in the way, don't cross it because then you're going to be trespassing. Occasionally there are parks that will let you collect. Most of the ones in Texas don't. But occasionally you'll find a park. There are locations that the Army Corps of Engineers runs that they do occasionally allow collecting. Your best bet is if you're wanting to find a good outcrop, take a day and just start driving and be ready to stop anytime you see an outcrop, and then take a look, see what happens. Because the other thing is, one outcrop to the next may be very, very different. You may go to one outcrop and find almost nothing but this fossil here, which I'll show you what that is in a minute. The next outcrop down the road may have nothing but this. The outcrops right here around CTC's campus, this is the most common fossil you will find. But I know of an outcrop just outside of Copper's Cove, on the other side of Copper's Cove, where you can't find this one. Instead, you find pretty much nothing but this one. So it's not something I can give you an exact location because every outcrop is different. You're going to have to do a little hunting on your own. If you do want to find fossils that are older or more, some of the different stuff, at the end, I will have my contact information, and I believe they're going to post it in Facebook along with the link for this lecture. Feel free to email me, and I can kind of give you an idea of where to go, what general area to go to see if you can find older fossils or younger fossils. But in general, your best bet is road outcrops. And then, like I said, the ones lean back and look like they're covered in gravel are usually easier, especially on kids. Hopefully that answered your question. So any
Thank
other
you, Dr.
questions?
Wegert.
Okay, any other questions or?
She also asked about how to sign up for a camp, but I'm not sure which camp.
The camps that I did were not actually through CTC. This was before I came here. I believe CTC, though, does run some kids camps, or at least they have in the past. They're done through continuing education. So you'd have to contact the continuing education department to see when they run those. I'm not involved in those right now, so I don't know what their schedule is like. But I do know they have a couple of different types of kids camps through continuing education.
Thanks so much.
No problem. So again, these are bivalves. These are a wide variety of them. This is, like I said, bivalves are one of the most common things you'll find. Here are a few more examples that you can find from different rock layers. These top pictures here, these are all, again, clams, and the bottom two here are actually another type of oyster. And you'll notice whole wide variety of sizes, from ones down here an inch or less across, up to ones that can be 4 or 5 inches across. There's some that are bigger than a dinner plate if you know the right place to find them and hunt very carefully. You can find all the sorts of different sizes and shapes. But these are some of the most common. Here in Central Texas, this one is probably the one you're going to find the most. It's called Texographia. Sometimes people just call it graphia, and they leave off the texa part. I usually see it as Texographia. That's the genus, and the species is Washitaensis. I actually give in my when I run face-to-face classes here on Central Campus, I often give an extra credit activity that has students going out to find fossils from the local area. I've actually toyed with the idea of making this one required, because if you can't find one of these, you haven't looked. These are pretty much everywhere. And most of these are what I and other geologists often refer to as a leverite, because you leave it right there. We pretty much only collect these if they are perfect. If they are perfect, or in the case of these two over here, have both top and bottom shell together, then we'll pick it up. Most of the rest we look at and go, chuck. They're that common. You will not have trouble finding these. Now, one interesting thing with these, bivalves have a muscle structure that allows, basically when they die and their muscles relax, it allows the shell to automatically open. So more often than not, when you find these bivalves, you will often find the shells separated because they died and they automatically opened and the two shells broke apart. This area, some types of bivalves are more common to find them closed, but for the Texographia, this area actually does have quite a few that are actually complete with the top and bottom shells together like these over here. More often than not, though, they will be separate. Other types of bivalves are more commonly closed, especially the clams. They are most likely going to be closed. But again, it varies from location to location and by species to a certain extent.
Dr. Wegert, I have an
Good.
interesting question.
Sure.
So I know I've been told in the past that you can look at like a tree trunk and see like the rings, and it can kind of tell you or date the tree for you. Does that apply to these fossils as well? Because I'm looking at the ridging and whatnot. Is that any indication of how old it is?
I don't know that they've actually figured out a way to exactly calculate the age, but what you're seeing as far as those ridges, those are actually growth lines. So that is
Oh,
showing you how it grew. What
okay.
ends up happening is the shell itself will grow a new piece of shell on the inside to extend a little further out to make the shell bigger. So what you're
Oh,
seeing with all of these lines here, those are the growth ridges showing how the shell grew. And the same with these bottom shells. These ridges are from the shell growing bigger.
okay. Interesting.
Um, I don't know that I'm not sure that it necessarily varies by age. Trees, because of the way they typically behave, their rings actually correlates to age. I don't know that it necessarily works the same for bivalves because they don't have growing seasons like trees do. So one growth ring or one growth line to the next may not necessarily be 1 year.
Well, thank you.
No problem. This is another very common one here, Exogyra Texana. You can probably get that Texas has a lot of these based on the species name. Exogyra, again, is a genus, so there's a wide variety of them. But this one, some areas here in the right around Central Campus, some areas are really heavy with the Texographia, but I've actually seen outcrops that this is the predominant fossil in the outcrop. You hardly find any Texographia, you mainly find these. It's another type of oyster, different species, but same idea, two shells. More often than not, they're separated. This specific fossil here, this is actually the same one, just flipped over. This actually has both shells together, top shell and bottom. Here's where the two would join. It's right in here. I've even seen some where the two shells stayed together long enough to be buried and preserved, and then in weathering out of the outcrop, the two broke apart. So you could see how they went together and see the infilling for the shell. So there's a wide variety of these, and you can find a variety of different ways that they've been preserved, and some get busted up. Many, though, in this area are still complete. Protocardia, this guy is a type of clam. This is one you're most likely to find both shells together and closed. if you look carefully, you can see some lines on them. These lines that you're seeing here, those are the growth lines, just like on the other. This particular type of bivalve usually gets preserved in a different way, though. So instead of seeing that recrystallized shell like in the previous two, this one you're seeing basically a piece of rock in the shape of the shell. There's rock molded to where the shell used to be to take on the same characteristics. Protocardia, this is another one, fairly common if you know where to look, and they can actually get quite big. Notice this sample is what is that, about 2.5 inches wide, give or take? I've seen some get up to about 3-4 inches for different species. And I've also seen some that look like Protocardia that are down to where they're maybe a 1/16 of an inch across. The main type of scallop we have in this area is called pecten. These are a couple. This one's not as well preserved. This one's has a much better preservation. Some of the smaller pieces are still intact. These two, the two shells are different. One's usually curved, one's flat. And then the creature was actually living inside in between the two shells. So this is the bottom shell. This is the top shell. Other types of bivalves. This is actually a different species of Exogyra. This one I'm still a little uncertain on the genus because I've seen a couple different genera that it could be. But this is where there's so many bivalves. There's a huge number of genera, huge amount of them. They're very easy to find. Slight differences give you a different species. But unfortunately, a lot of these species, they start to look a lot alike. So this is where it takes a little bit of digging if you really want to get down to genus and species names. But in general, all of these are bivalves. They're all a clam, oyster, or scallop. These are more examples of clams. And again, you can see some of them will have ridges on them. Some don't. Some will have the growth lines very apparent. Some don't. It depends one species to the next. Now, gastropods are another very, very common group here or another common fossil type here in Central Texas. We don't have as much variety in them, but we often get some of very, very large sizes. Gastropods are basically snails. We're used to snails being up here on the land surface, right? Well, there's also snails in the ocean. These are ocean-dwelling snails of, as you can see, various sizes, everything from about maybe a little over 1/2 inch long to these ones here that are about 3 to 4 inches wide, and in some cases can be even longer than they are wide. All of these, though, were a type of snail. Now, you'll notice the way they coil. They coil almost like ice cream on an ice cream cone, swirling around and going up for the most part. That's one way to tell you've probably got a bivalve. Or sorry, gastropod. There is one other type of creature, though, that does coil like that can sometimes be confused for it, and I'll show you that fossil here in a few minutes. But here's actually a modern gastropod that has been cut open so you can see what the inside of the shell looks like. Notice you got a column here in the middle, but then the area where the snail would be seems to kind of coil around. It's just hollow the whole way up. That way the snail can pull back into its shell when there's a predator around, and when there's no danger, it can come out of its shell to move and graze. That's going to be a big difference between this and our next group we're going to talk about. So there's two very common genera of gastropods here in this area. The first is Turatella. Now these can be relatively small. They can be decent size as well. But these guys tend to be on the smaller end of gastropods. And one thing you will sometimes see is some of the Teratella fossils will actually have the shell material that's being recrystallized preserved with the shell or with the fossil. This fossil here, you see the kind of darker material here? That's actually where the shell got recrystallized. It got changed to a different mineral, but that mineral, the crystals, stayed. And the white material you're seeing in between is sediment that filled up that coiled inside of the shell. When the whole thing turned into a rock, you now have rock on the inside of the shell and these crystals replacing the shell itself. Most of the samples, the crystals are gone. Occasionally, you do find ones like this where the crystals are preserved. I've even seen some in this area that have been what we call pyritized. The original snail shell was changed into pyrite crystals. Pyrite is more commonly known as fool's gold. So you can occasionally find fossils of these guys that are pyrite, fool's gold, in place of the shell. They're not terribly common, but I have seen a few come out of the local rocks. Now, Lunatia, this is the other major genera that seems to be found in this area. These are big snail shells. As you can see from the scale here, these are big. They're large snail shells. And I haven't seen too many of them that still have shell material preserved. But you can see they look kind of like the ice cream cone swirl shape. That tells you, again, pretty much you've got a gastropod. Bigger ones typically are from this genera, but there are other less common ones as well. Now, gastropods are most commonly confused for this next group, ammonoids. This is the one that I get a lot of people excited about, and a lot of people always ask me, where can I find a good one? This is the one that people always seem to want to find. Ammonoids, they're basically a squid-like creature with a shell on its back. And what you're seeing is the preserved shell from this squid. Now, the bad part is the shell typically gets broken because they can be very, very large. The larger they get, the more likely the shell is to break. Ammonoids, as you can see here, there's a very small one here. This one is found in an area up close to Waco. Up towards the DFW area, they've actually found ammonites the size of a wagon wheel, which are commonly referred to as wagon wheel ammonites, based on the size. This area, we don't typically get them that large, but we can get diameters about the width of a typical human torso as kind of the high end. And sometimes you will find them intact. These things are going to coil. So if you look closely at the zoomed in picture of this one, or this picture over here, they start out small, and as they grow, their shell coils around, getting bigger and bigger as it coils. And you'll notice many of them will have this pattern of ridges on the outside. Some ridges are big and thick, some are thinner. It just depends one species and one genus to the next, how big and how well developed those ridges will be. One other thing that you can look for, and I'm actually going to stop sharing this for just a minute so I can show this to you. One way to tell you've got an ammonite is to look where it breaks. For instance, this fossil here. Do you see the funny pattern here on the end? This pattern on the end, this is from this is basically a septa, a suture inside the shell. I'll show you what that means here in a second. But if you find a shell that has this kind of a pattern on one end or the other, you are looking at an ammonite. Now, if I go back to this, here's what I'm talking about when sorry, go ahead.
Oh, I just saw another question,
Go ahead.
and it's a pretty easy one. What tools do you recommend uh, for hunting fossils?
Okay, in general, in this area, you really don't need any. Most of this area, you can typically find them lying on the surface just like gravel, so you don't really need any tools.
Wow.
Um, Occasionally, you'll find something in a rock. More often than not, if you find something in a big slab of rock, it's probably in a chunk of rock you're not going to be able to get out easily.
Uh,
And typically, if you do find something in a rock, keep hunting for about 5 or 10 more minutes, and you'll probably find one that's already weathered out. Ammonites are about the only thing I occasionally find in a rock that I ever even bother getting out a tool for. If it's not an ammonite, I usually just look at it and go, eh. I walk on and I find more of them later.
uh,
It's the lovely thing about Central Texas. You don't have to worry if you can't get one of them. There's more of them coming. Just keep hunting a little bit longer.
Great. So you can actually go out on a little
Yeah.
hunt with no tools.
Take
Okay.
your best bet. One, take water with you because, well, it is Texas. And you know how hot it gets in Texas. So take some
Yes.
water with you. Take a bag. And the only other thing you might want to keep handy is you might want to keep some paper towels because occasionally there are some fossils, depending on where you go, some of the fossils can be somewhat delicate. If you
Uh,
see a fossil that you're worried that it's a little delicate, take a paper towel, fold it up a couple times, lay the fossil on it, fold the paper towel a couple times, put it in a bag. And the paper towel will usually cushion it enough for you to get home with it. One thing I don't recommend you do not put water on them. There are some fossils, especially there's a couple places up around Waco where you can get access to this one specific rock unit. And some of the fossils there, like this ammonite here, have a dark coating on them. The problem is if you get this wet and scrub it even a little bit, you can actually get rid of that entire dark coating. And then that fossil ends up looking about this color over here, only nowhere near as pretty. So don't get them wet. Um, in general, cleaning up a fossil, it takes practice and it takes work. If you've got something you want to clean up or want to know how to clean up, because again, it depends on which type of fossil you have, depends on what you need to clean off of it. I can kind of go over that, or the other gentleman whose contact information I'm going to give you, he's actually a little bit better at that than I am, because he's actually cleaned a lot of invertebrate fossils, so he knows a lot of this. Uh, Sometimes dental picks will work. The hard part is cleaning what you don't want off and not damaging the fossil itself. So your best bet is when in doubt, leave it as it is, and then email myself and or the other instructor I'm going to give you the information for, and we'll kind of walk you through what will work or what won't work, and give you an idea of whether or not it's a good idea to even try. And a lot of times it's sometimes better to leave a little bit of the rock on there. It does kind of give it a little bit of character, but also it shows a little bit of the regular rock that it was in. And a lot of times geologists, we actually will leave some of the rock on because it will also sometimes hold the fossil together a little bit better. I've seen a couple of fossils where we tried cleaning all the rock off and the fossil disintegrated on us as we tried to clean the rock off. So that's one that it's really more of a case by case basis how you want to clean them. So like I said, my contact information and the other gentleman's contact information will be at the end. If you have one in particular you'd like to, contact us about it and we'll kind of walk you through what to do or not. Were there any other questions or?
no, sir.
Okay.
Thank you.
All right. Well, back to ammonites. This picture, this is actually it's a modern cephalopod. It's not an ammonite. It just happens to have basically re-evolved the same general shape because the shape gives it an advantage. This is actually called a nautilus. Nautilus works in a lot of the same ways as an ammonite. The true ammonites have died out. This group evolved the same features, or at least some of the same features later on. Now this shell's been cut in half, so this is just half of the shell. But we did this so you could see the inside. This big area here, that's where the squid's body would be. And then its tentacles and its head and everything would stick out this end. And the body is here protected by the shell, but the shell also gives it another really cool advantage, another really cool adaptation. You see how you got these little walls here subdividing the rest of the shell? These little walls have a little tube through them. They have an opening in each wall. And while the creature was alive, the creature can actually force water and air behind its body into these chambers. And by varying the amount of water and air in those chambers, the creature will either rise or sink in the water. In a way, they behave a lot like a submarine. Submarines, when they want to go down, they take water and they fill tanks on the ship with water to make the ship heavier and make it sink. When they want to go up, they force the water out and force air into those tanks, making the ship more buoyant and allowing it to rise. This creature behaves the exact same way. These chambers back here allow it to go up or down. That suture I showed you on this sample, that suture pattern, that pattern comes from one of these septa, one of these dividers in the old shell. So this is where one of those dividers would have been. And because the shell was there, it made a weak spot that allows it to tend to break in that location a little easier. So you'll often find ammonites that the end will look something like this because of the septa involved in the shell itself. Now, the most common types, there's two very common types from this area. This one is called Oxytropodocerus. I always struggle with that name. This is one of the most common, and I'm going to stop sharing again because I'm going to show you another example of this. So you can get an idea, based on the size of my hand, how big the shell can be. This is actually not the biggest I've seen. They can get bigger than this. But you see all these lines running on the outside? When you start to see that pattern, it's probably an ammonite. Now, the second most common type, and if you can't figure out that they're common in Texas, well, read the name. They're common in Texas. Texonides is the ones that typically have a bigger ridge to them. And these are ones that actually tend to get bigger. You saw the size of the can never say that word. Oxytropodocerus that I held up. If I put that one on the inside of the curve for this guy, it would actually be much smaller. It wouldn't quite match the inside of this curve. This guy was, again, a lot larger. This guy, if he had been complete, would have been about the width of kind of a typical human torso, roughly. So we're talking a good size shell. And this one, as you can see here, has been broken. Note the pattern. The same as the pattern in this one that I held up. That's the suture pattern. When you see these ridges, if you look carefully, you will often see that suture pattern somewhere along that same fossil. Now, I said these guys could get very, very large. Do they have to be very, very large, though? No. This guy's not all that big, is he? Note the scale. He's only about 3.5, 4 inches across. One other thing to remember, different species will often have different sizes, But also, not all fossils are of adults. You may find juveniles or even basically babies that died and got buried and preserved. So you can see a wide variety of sizes within these groups, one based on how old they are, but two based on which species they are. Some species will be very, very large, some not so much. And then some, like this one again, not even an inch across. So you can find very, very small ones as well. So like I said, these are the ones that a lot of people really want to find. I've seen people who have found enough of the big ones that weren't really well preserved. They were kind of badly weathered, but you could tell they were an ammonite. I've actually seen people that have collected multiples of those and used them as landscaping. In and amongst their flowers, they had these large ammonites sitting on the ground. I've even seen people that used them as stepping stones because they're that large. So, common fossil in this area. Unfortunately, most of the ones around here are broken. Occasionally, you do find a complete one, though. Now, you might remember I said that there was a type of ammonite that's often confused for a gastropod. This guy. Ammonites, the ammonoids in general, they coil in one plane. So if I stop sharing here real quick, if you look at this fossil, it's in one plane, coiling round and round and round. Well, that's most ammonites. This guy, though, looks more like the gastropod, right? Coiling around and going up. This type of ammonite has only really been found in the Cretaceous. It's a very rare group of ammonites that we do have here in Texas from the Cretaceous period. Don't typically find this in other time periods, and I've never seen one that came from anywhere but Texas. There probably are a few from elsewhere, but most of the samples I've seen come out of Texas. This creature is an ammonite. If you get a well-preserved sample and the end gets broken off, it will usually show that suture pattern as well. One way you can tell it's likely an ammonite and not the gastropod, look closely at the outside of the shell. Do you see the ridges? If you see a gastropod with those big ridges repeated around it, going down it as you go up the gastropod shell, that's most likely an ammonite, not a gastropod. And like I said, when in doubt, feel free to contact us. We'll be glad to take a look at what you've got and give you our opinion. But on Turalites, if you look closely, there's almost always a ridge pattern to it. That ridge pattern is what tells you this is typically the ammonite, not the gastropod. And as you can see, this guy was pretty big. I've also seen them down to where they're only about that long. It depends, again, which rock unit do you go to? The Del Rio clay, I've actually found a lot of Turalites that are less than half an inch long for the whole shell. On the other hand, this Turalites is bigger than my fist. It's almost the size of both my fists together. So again, wide variety of shapes and sizes, different rock units, they may show up different. But if you see something that looks like a gastropod with this line sets of ridges going around it, it's probably actually an ammonite. And it's a very rare type of ammonite at that. Now, one of the other common fossils that I get a lot of people asking me about are echonoids. You've probably also heard these as sea urchins or sea biscuits. Echonoids are another not too uncommon fossil around here. You can find them. Many of them, like this example over here, are pretty badly weathered, so you can see the general shape, but you can't see a lot of the features on them, unfortunately. Others are very well preserved. You can see all the nice details really clear. Like this one's got pretty well preserved details, so does this one. So, variety of shapes and sizes, but the two most common, actually, there's three common ones. Heteroaster is probably by far the most common echonoid you will find. This is the one when somebody brings me an echonoid from this area, it's almost always this guy. And if you look, they're even kind of heart-shaped. There's a little kind of a divot up here, making it almost shaped like a heart. So a lot of people actually call them heart urchins for that reason. And if you look closely at this one's actually pretty well preserved. You can kind of see a pattern here, 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 and here, with a pattern of little lines going across. Econoids are in the same phylum as starfish. They're closely related to starfish. They often have a pattern of fives. Basically, that whole group, starfish, sea urchins, all the other varieties that are related to them, they have five-sided symmetry. So there's always five of something related to them. In this case, there are five areas here where there's usually hairs that would have stuck out from the original creature. These guys will often have tube feet. They can have spines. Different versions have different features, but they almost always have this pattern of five, what they call ambulacra is the fancy term for it, up here on the surface. You may also note some holes here in the center, some little tiny ones. And on this guy, you can see a hole at the end. Different ones have different orientations, different pattern for the internal organs, but usually you can find at least two holes, one for the mouth and one for the other end. More often than not, the mouth is usually on the bottom. But these kind of act like sand dollars do today. So they can be on the surface, they can burrow to a certain extent into the dirt to look for food. These two genera are more like true sea urchins we're used to today. The ones that have all the spines sticking all over. And if you look, you see the bumpy patterns to these guys? Every one of these bumps is one spine. So every one of these bumps had a spine sticking off of them. If you've ever seen a porcupine, these look like little porcupines moving around on the ocean floor with spines in every direction to keep predators away. And then usually the bottom will have a hole in it with a beak. And when they want to eat something, they actually walk up on the top of it, and then the beak starts eating down into what's under them. Now, Fimosoma, fairly common in this area. It's the bigger ones. Usually they're an inch or so across, kind of at the low end. We do have Selenia that kind of related, different genera, fewer bumps, so fewer spines, but they tend to be a lot smaller. These are going to usually be like a quarter-inch, half-inch tops across usually, some rarely bigger. But when you see the bumps on them, that means it's more of a true sea urchin. The ones without are usually a little bit more like a sand dollar in the way they behave. They're more like a sea biscuit. And depending again on where you go, they can be preserved in different ways. The Del Rio clay, these two are examples of sea urchin fossils from the Del Rio clay. This is a spine. If you look here, this funny pattern here at the bottom, the end is actually cupped. So that knob on the body, the cup sits on top of it. And there's a little bit of soft tissue connecting the spine to the knob on the body itself to allow for a little bit of flexibility in that spine. This is actually a piece of the sea urchin's body. Sea urchins, the shell is around the outside and all the internal organs are on the inside. So on occasion, after they die and get buried, they may get crushed, in which case you preserve pieces of the shell instead of the whole fossil. From the Del Rio clay, it's pretty much always pieces that you find like this. You don't typically find the whole creature. But you can occasionally also find spines. And we do have other types of echonoids, like this one here, which is a very rare type. I think I've only seen a couple of these come out of this area, but we do occasionally find them. So echonoids, pretty common in this area. Mostly, like I said, though, the hard urchins are going to be the most common. These, the Fimosoma is probably the second most common. Our next group are Rudist Bivalves. This group only exists in the Cretaceous. They show up about the middle of the Cretaceous, and from kind of around the middle of the Cretaceous all the way through the end, this group becomes the main reef builder. In the Cretaceous, corals did not build reefs. These guys did. I've actually seen Rudist bivalve fossils that were up to 2 or 3 feet long. Most of the ones we find here, they're for the most part much smaller, because this area is lower Cretaceous. These are what they look like when they first evolved. They first started showing up. If you get into some of the upper Cretaceous rocks, especially some of the ones closer to the end of the Cretaceous time period, those Rudist bivalves got to very, very large sizes and were building whole reef complexes like corals do today. You'll notice they've got a growth pattern here on the outside, kind of like the bivalves did. The big difference, though, is they tend to grow up in one big long tube on the bottom, and they have a small flat lid to them. That lid usually breaks off and is not present. But you will see growth rings on the fossil as it grew up. And typically, if you notice this sample here and this one here, there's a hole in them. That hole is usually lined with crystals. That hole is where the bivalve itself, this basically oyster essentially, lived. This oyster was down inside that hole, had a lid on the top, would pull the lid back and extend an organ out to pull in food. And then if danger came around, they pull back, the lid shuts, and the predator can't get at them. These guys, like I said, around here, this is kind of early on when they first start showing up, so they're relatively small. But we do find them. I usually get, well, pre-COVID, I would usually get about 1 to 2 people every year, every school year. So about 1 a semester coming to me with one of these and saying, "What is this?" Because it's not a common group. This group, like I said, is only around in the Cretaceous. And at the end of the Cretaceous, when the dinosaurs go extinct, these guys go extinct as well. So it's something special from the Cretaceous, something that you go anywhere else, unless they have Cretaceous rocks, they're not going to have. I had never actually seen one of these until I came to Texas. Now we do still have corals. There were corals around, but notice the scale. They're tiny. I've actually got a couple that are down closer to more like a 16th or 1/32nd of an inch. So they're really, really tiny. These are some of the biggest I've seen at about a 1/2 inch, 3/4 of an inch across. The corals in the Cretaceous didn't get very large. They weren't doing real well in this time period. The bivalves were doing great, but you do occasionally have corals. And the way you'll know it's likely a coral, if you notice all 3 of these, they have a pattern of ridges running down the side. And again, it depends on the fossil. If you look on the big circular ends here, here, and here. Sometimes if you look at that, you will see a pattern of radiating lines on the end. If you see that pattern of radiating lines, there's an excellent chance you're looking at a coral. So not terribly common. These are going to be one that you may have to hunt 5, 10 outcrops. You may have to hunt for a few months before you find one. I'm not talking hunt every day, but you may have to spend a while hunting before you find one of these. I think I've only found, okay, in the Del Rio clay, I've found about a dozen. Outside that unit, I think I've only found 3 that I've personally found. And I've hunted for a while. So this is not something you're going to find very easily. If you do, it's kind of special because you don't typically see these. Another one that often fascinates people are worm tubes. Everybody knows what worms look like, right? Does this look a little like you got worms growing on this fossil here? That's not the worm. This specific group of worms called serpulids, they actually secrete a shell. They create a shell attached usually to another creature, and they live attached to that other creature. And they use the tube as a place to live. So inside this tube, when these creatures were alive, there would be a worm inside that tube. But the tube is just a little bit of shell secreted around the worm to give it protection. It's not attached to the body in any way. And you can see, if we go zoom in a little bit, you can see it kind of zigzagging and swirling back and forth on this guy, going all sorts of different ways. This is probably at least 2 or 3 worms growing on this one shell. I've actually seen a fossil where if you turn the fossil one way, on the bottom you see this lovely clam shell, about the size of your spread out hand. Good size bivalve shell. You flip the fossil over and you can't see the bivalve shell anymore because there was a layer about this thick over the entire shell that was nothing but these worm tubes. One worm tube stuck to another worm tube over the whole shell. Down in this area, we don't typically get the worm colonies like that quite that big, but we do often find them, especially attached to bivalves. Bivalves are by far one of the most common fossils that these will attach to and live on. And sometimes you do get them broken off and just by themselves. Some will look kind of soft and rounded like a worm. Others may have ridges along the ends of them. One thing that you will note is if you see the end will often, it's not hollow anymore, but it'll look like it should be. It'll look like you can see the shell and there's something else on the inside filling it up, because that's what you have to do to preserve this, is you have to fill that tube up so that it doesn't get crushed. But some will have ridges, some won't. And again, note, many of them are very, very small. I've had a lot of people bring me fossils, lovely bivalves, and they go, what is this? I ask them, which one? What do you mean? Well, you've got 2 fossils here. They didn't even notice that the worms were on there. So you got to look carefully, but sometimes you will see these worm tubes attached to other fossils. Now, when I talked about bivalves, I said that the shell was asymmetric, right? This is a brachiopod. I'd like you to look carefully at these 2 pictures. If I were to, let me see if I can get this to work right. If we are to draw a line, let's see how steady my hand will be. Not too bad. We draw a line through the middle. Look at the left and the right. They look like they're the same, don't they? Brachiopods are symmetric that way. When you look down on one shell, the left side and the right side, assuming no damage to the fossil, left and right side are equal. Brachiopods are often referred to as lamp shells, because if you picture the old Aladdin style lamp where you have curved piece on top and bottom, and you got that little piece on the bottom that sticks out with a hole for the flame, that's the way they tend to grow, or at least some of them do. And if you look closely, there's a little hole right here at the end, almost like the hole on that Aladdin's lamp. This is why they're often called lamp shells, because they resemble those old school lamps. That hole there is actually where one soft part from the creature would extend out of the shell and attach them to the ground. And then the shell itself could open, and water passing through would get filtered by the creature to pull out any food. One other difference between actually two other differences. One you can barely see on this one. You see there's a little bend here where the top shell and bottom shell come together. There's a little bit of a bend there. That's called a sulcus. Brachiopods have them, bivalves don't. So if you see it, even if the shell's busted, if you see that bend, think brachiopod, not bivalve. The other big difference is you notice there's top and bottom shell together. Brachiopods and bivalves are opposites in another way. Their muscles work different. In a bivalve, when the muscles relax, the bivalve shell opens. So they actually have to relax their muscles to open the shell and actually get food coming in. Brachiopods actually have to tense their muscles to open the shell, which means typically when a brachiopod dies and all of its muscles relax, the shell closes. So it's very, very rare to have a brachiopod broken open and have two separate shells. They're almost always together because their muscle structure is set up to close them. But like I said before, it's worth reiterating. Don't expect to find many of these. I found one. And my colleague here is actually, fossils are one of his specialties. He looked at the fossil and he had never seen it. He had seen others, but he had never found one of these here in Central Texas. They're that uncommon. To find one of these is going to take a lot of effort on your part if you want to find one. Most areas, they don't exist. They're that rare in the Cretaceous time period. I have exactly one. And I probably will never find another. Especially since I can't remember where I found that one for certain to begin. I can't remember where the outcrop was. So I can't go back to find more. Now, another fossil type that some people will find in this area is petrified wood. And you might look at this and go, wait a minute, I thought we were seafloor. Well, we were. But when you get a big storms can wash things out to sea, right? So trees along the coastline could get knocked over, carried out to sea. When you have rivers dumping into that Cretaceous interior seaway, if a log goes floating down the river empties into the sea, so where does the log end up? Out in the ocean. So we do occasionally find petrified wood in this area. And depending on how well it's petrified, most of the stuff around here does not do a very good job of preserving internal detail. You can sometimes see a little bit of a hint that suggests that it's wood, a little bit of lineation, lines, patterns on it. Sometimes not so much. But we do typically have petrified wood around here. And petrified wood, this is no longer wood, this is actually quartz instead. So it's a much, much tougher rock than most of the fossils and most of the rocks around here. So it tends to stay intact pretty well. Most of the petrified wood I've found, I did not actually find in the rock. I typically find it in rivers and streams as some of the gravel washing down that stream, because while the rock around here is much softer than the wood, the water breaks down that rock, the wood pieces come out, but they hold up real well as they go tumbling down the stream. So they end up in stream deposits and end up preserved there pretty well. But we do have petrified wood. Now, I did want to talk a little bit about some more modern stuff, because occasionally I do get somebody that brings me something that's younger. We do have younger sediment layers deposited in this area from the Quaternary time period, basically modern, or just before the modern time period. Now, at that time, the animals we're used to were the majority of what's running around. So deer, bison, wolves, coyotes, um, turtles, that kind of stuff is the most common stuff that's around. But in the Quaternary, we also had a few oddball creatures that were still roaming North America. For instance, most people know that horses are not native to America, right? That's actually wrong. We used to have horses here in North America. They died out. The horses we have now were ones that were native to Europe that got brought over. But we originally had horses here in North America. They all died off. And we had mammoths roaming this part of Texas. Specifically, we had Colombian mammoths. Now, you might be looking at that going, huh? Y'all have heard of a woolly mammoth, right? These are the ones that tend to be up north. They like the tundra, they like the cold areas. Colombian mammoths preferred more southern climates. They preferred it a little warmer. They weren't quite as shaggy, but they were bigger. In general, an adult would stand about 11 to 12 feet tall at the shoulder. Colombian mammoths are what they found up in Waco at the Waco Mammoth site. In that site, they found over 25 mammoth skeletons preserved in the sediment. And there's more there. My understanding is when they were starting to build the museum there on the Waco Mammoth site, one of the things they did was they drilled and took cores of the area around it to figure out where would be stable enough to build. One of the cores, when they pulled it up, had a piece of mammoth bone in it. So they drilled into a mammoth bone as they were testing the area around. Occasionally, I get somebody that will bring me a piece of a mammoth. Now, most often, it's a mammoth tooth, like this one. Mammoth teeth are not like ours. They form as a series of plates, all stacked one next to the other. And they end up forming a relatively flat but somewhat rough surface for grinding up the plant matter. Teeth are the toughest bone in your average vertebrate's body, so they're more likely preserved than any others. This is a tooth we have here at CTC. This is one mammoth tooth. I've had a couple of people bring me mammoth teeth to identify. I've even had somebody that brought in part of a mammoth tusk. It wasn't the whole tusk, it was just a little piece of it. But it had the original bone material intact. If you happen to be down near a river or digging in sediment that's relatively young, you do have the potential to find some of the younger fossils as well. Keep in mind, don't be digging into somebody else's property. That's called trespassing. That will get you into legal trouble. But occasionally I'll have somebody who, on their own property that happens to be near a creek, they may find something like this and bring it in. So we do have some younger things in this area. And if you are interested in mammoths, or if you've got kids that are interested, there's two other really cool locations you can go to that are not terribly far from here. The Waco Mammoth Site is a national park up in Waco. There's not a whole lot there right now, but they still have, you can go on the tour through the Mammoth Site. You can still see some of the bones in the ground. You also have the Mayborn Museum. It's in Waco, just off of I-35. They've got mammoths, they've got mastodon bones, they've got a whole turtle skeleton. They have a wide variety of fossils and other materials from the past. Great place to go and visit, especially if it's a really, really hot day and you don't want to be outside, because they've got air conditioning. So you get to see it without the heat, which is always nice, right? So those are a couple other areas that you can go, a couple other ideas for you if you're looking for something to do. And I know we're needing to wrap this up, but here's the contact information for myself and Mr. Chris Gocher. He is one of our science associates here. He helps out with the geology labs, and he knows fossils very well. So between the two of us, we'll be able to identify just about anything you likely bring us. So if you've got any questions about a specific fossil you found, want to know where to find different types of fossils, feel free to contact us. We're more than glad, more than happy to help you out. And email is going to be the best because we do have to teach. So I give you my phone number, but if you call, I'm probably in class. So it's better you just email me, because that way also, if it's a fossil you're wanting identified, please send me a picture, because then I can get an idea. And even if I can't tell for certain what species, I can at least try to get you close. So thank you all for your attention. Thank you all for coming. And if you've got any questions, I'll be around for a little bit. I can answer whatever questions you have. Thank you.
Thank you. Thank you. I do have one quick question though. I've seen a lot of what you've shown today over at Belton Lake. Is that one of the places that you don't take stuff from?
It depends. It depends on where you're at. If you're inside of a park, check the park rules.
Okay.
I've never found a park in Texas that will allow you to collect, but in other states, I've actually been to a couple of state parks that they explicitly stated in their rules, collecting is allowed.
Okay. All
So
right. So everybody
it
check.
depends on where you're at. Double check. If you're in a park, triple check with them so you're not breaking the law. Because
Okay.
they will, if they do catch you, they will give you a fine.
Okay. Good to
But
know. Good to know.
this is
Janice,
why
is
I say
anybody? Yeah.
outcrops are usually the best.
Yeah.
Sorry.
Janice, are there any other questions?
Nope, not that I can see.
Okay. Well, Dr. Wegert, this was amazing and fascinating, and I want to go out right now and start looking around on the ground. I know we have a coworker here that he spends his whole entire lunchtime, Mark Browning, looking for fossils all over the campus. So I know we have them just sitting on the grounds here too.
Yeah, we do. You don't,
Mhm.
anywhere you see bare rock around here, you're probably going to find fossils. One other thing that I did forget to mention, there are a number of books specifically about fossils from Texas, because some of our fossils here are very, very exceptionally well preserved samples. So they're ones that a lot of people around the world compare what they find. They compare it to what we have. So there are whole books written about Texas fossils. Our CTC library does have several of these books. So if you're interested and are a CTC student, you can come and read those books in the library, and some are even available for you to check out. So there are
Well,
resources in the library as well to help you out.
and guys, we actually have a specific geology LibGuide. So if you go to our website and you find study guides at the bottom or LibGuides, look down that list. We have a geology, and we've pulled out some of our most recent geology books. So we've kind of given you a shortcut. Thank you so much, Dr. Wegert. We have tried to have this event for what, a year and a half now? So maybe when we're able to go back into in person, we can do that scavenger hunt that we talked about. But
Yeah, I'll
we
be
got to
glad to
change.
help out with that. Yeah,
Yeah.
it's been a bit of a rocky ride for this one, but
That's okay. We are going, you gave us great information today to get started on our search for fossils. Thank you so much again. We truly appreciate you taking the time to visit with us. And everyone, we will be switching gears for next week. Our virtual events are on Asian Pacific Heritage. We will have a life story from Grace Kim, who is over at Baylor University in Waco, speaking of Waco. And we will also have Fort Hood history teacher Michael Walls, who's going to give us some information on the, history of Asian Pacific people who have contributed to American history. So make sure you join us Monday and Wednesday for that. Thank you again, and you guys have an awesome day. We wish that the weather would just continue to stay this temperature. So go out and enjoy it before it gets way too hot in Texas. So thank you again, and we'll see you guys later. Thank you, Janice, and you take us out.